The most advanced fighter jets ever created are often described in terms of speed, stealth, or firepower, but those labels only scratch the surface of what makes them truly exceptional. These aircraft are not just weapons, they are complex systems built around data, sensors, and decision-making dominance. Designed to operate in environments where threats evolve in seconds, they redefine how air combat is fought. Pilots are no longer just flying, they're managing information at a level never before seen. At one point, these aircraft were so advanced, other countries couldn't even understand them, let alone counter them effectively. The Lockheed Martin F-22 Raptor is widely regarded as the first true fifth-generation air superiority fighter to enter operational service. Developed by Lockheed Martin in partnership with Boeing, the aircraft emerged from the Advanced Tactical Fighter program during the final years of the Cold War. Its primary objective was to counter next-generation Soviet threats, but by the time it entered service in the mid-2000s, the geopolitical landscape had already shifted. Despite this, the Raptor was not redesigned for a new era. Instead, it retained its original purpose as a platform built to dominate any contested airspace, regardless of opponent or environment. Unlike earlier fighters that emphasized speed or maneuverability in isolation, the F-22 was designed as a fully integrated combat system. Its defining characteristics are stealth, sensor fusion, and situational awareness. The aircraft's radar cross-section is extremely low, allowing it to operate inside heavily defended airspace without being easily detected. This is achieved through a combination of shaping, internal weapon carriage, and radar-absorbent materials. Weapons are stored in internal bays to preserve stealth, limiting drag and reducing the aircraft's visibility across multiple detection spectrums. Physically, the F-22 is a large twin-engine fighter. It measures approximately 18.9 meters in length, with a wingspan of 13.6 meters and a height of 5.1 meters. Its empty weight is around 19,700 kilograms, with a maximum takeoff weight exceeding 38,000 kilograms. Compared to legacy fighters like the F-15, the Raptor maintains a similar size, but incorporates entirely different design priorities. The airframe uses a blended wing-body configuration with angular surfaces optimized for low observability rather than aerodynamic simplicity. Power is provided by two Pratt & Whitney F-119 engines, each capable of producing over 35,000 pounds of thrust with afterburner. These engines ensure supercruise, allowing the aircraft to sustain supersonic speeds without using afterburners. Maximum speed is estimated at around Mach 2, but operational performance focuses more on sustained high-speed engagement rather than peak velocity. Thrust vectoring nozzles provide enhanced maneuverability, particularly in close-range combat scenarios, allowing the aircraft to maintain control at high angles of attack. The F-22's avionics represent a fundamental shift in how pilots interact with combat information. Its onboard systems integrate data from radar, electronic warfare sensors, and external sources into a single coherent picture. This reduces pilot workload while increasing decision-making speed. The radar, an AN/APG-77 active electronically scanned array, is capable of tracking multiple targets at long range while remaining difficult to detect by enemy systems. Communication and data sharing capabilities allow the Raptor to function as both a shooter and a coordinator within a larger networked force. Operationally, the F-22 is designed to achieve air dominance at the earliest stages of conflict. Its combination of stealth, speed, and situational awareness allows it to engage adversaries before being detected, often determining the outcome of an engagement before it fully develops. While it has limited ground attack capabilities, this is not its primary role. The aircraft exists to control the airspace, ensuring that other assets can operate without interference. In essence, the F-22 Raptor is not defined by a single performance metric. It's the result of a design philosophy that prioritizes information advantage, survivability, and first-look, first-shot capability. Rather than reacting to threats, it is built to neutralize them before they become relevant. The Lockheed Martin F-35 Lightning II is a fifth-generation multi-role fighter developed to replace a wide range of aging aircraft across the United States and its allies. Designed and produced by Lockheed Martin, the program was built around the concept of a single adaptable platform that could perform air combat, strike, and intelligence gathering missions within one unified system. Unlike the F-22, which focuses primarily on air superiority, the F-35 was created to be flexible, scalable, and deeply integrated into modern network-centric warfare. The aircraft exists in three primary variants, each tailored to specific operational needs. The F-35A is a conventional takeoff and landing version used by air forces. The F-35B introduces short takeoff and vertical landing capability for marine and expeditionary operations, and the F-35C is optimized for aircraft carrier use with reinforced landing gear and larger wings. Despite these differences, all variants share a common design philosophy centered on stealth, sensor fusion, and data dominance rather than raw speed or maneuverability. Physically, the F-35 is smaller than many legacy fighters, but larger than lightweight platforms. It measures approximately 15.7 meters in length, with a wingspan ranging from 10.7 to 13.1 meters depending on the variant, and a height of about 4.4 meters. Empty weight is roughly 13,000 kilograms, with a maximum takeoff weight exceeding 31,000 kilograms. The aircraft's shape is carefully engineered for low observability, with internal weapon bays, aligned edges, and radar-absorbent materials reducing its visibility to enemy radar systems. Unlike older multi-role fighters that rely on external payloads, the F-35 prioritizes stealth even when fully armed. Power is provided by a single Pratt & Whitney F-135 engine, one of the most powerful fighter engines ever produced. It generates over 40,000 pounds of thrust, enabling the aircraft to reach speeds of approximately Mach 1.6. While this is slower than some dedicated air superiority fighters, speed is not the defining feature of the F-35. Instead, its performance is optimized for survivability and mission effectiveness within contested environments. The F-35B variant incorporates a complex lift fan system, allowing it to perform vertical landings, a capability rarely seen in supersonic jets. The defining characteristic of the F-35 is its avionics and sensor integration. The aircraft is built around an advanced sensor fusion system that collects and processes data from multiple onboard and external sources. Information from radar, infrared sensors, electronic warfare systems, and allied platforms is combined into a single real-time picture displayed to the pilot. This approach transforms the pilot's role from managing individual systems to overseeing a comprehensive battlefield view. The AN/APG-81 radar and the distributed aperture system provide 360-degree awareness, allowing the pilot to detect, track, and engage threats across multiple domains simultaneously. Operationally, the F-35 is designed to function as both a combat aircraft and a node within a larger information network. It can share data with other aircraft, ground units, and command systems, effectively extending its capabilities beyond its physical presence. In many scenarios, the F-35 does not need to engage directly. Instead, it can identify targets and pass that information to other platforms, coordinating attacks while remaining difficult to detect. In essence, the F-35 represents a shift away from traditional measures of fighter performance. It's not built to outfly every opponent or outrun every missile. It's designed to outthink, outsee, and outcoordinate. Its effectiveness lies in its ability to control information, reduce uncertainty, and operate in environments where older aircraft would struggle to survive. The Sukhoi Su-57 represents Russia's approach to fifth-generation air combat, combining stealth features with high maneuverability and multi-role capability. Developed by Sukhoi under the PAK-FA program, the aircraft was intended to replace aging Soviet-era fighters such as the Su-27, while addressing the growing dominance of Western stealth platforms. Unlike its American counterparts, which prioritize stealth and sensor integration above all else, the Su-57 reflects a more balanced design philosophy that retains traditional strengths and kinematic performance alongside newer low-observable technologies. The aircraft entered limited service in the early 2020s after a prolonged development period marked by technical challenges and shifting requirements. From the outset, the Su-57 was designed to operate across a wide range of missions, including air superiority, ground attack, and electronic warfare. Rather than focusing exclusively on beyond visual range engagements, it was built to remain effective in both long-range and close-range combat scenarios, reflecting Russian doctrine that still places value on maneuverability and pilot-controlled engagements. Physically, the Su-57 is a large twin-engine fighter with a length of approximately 20.1 meters, a wingspan of 14.1 meters, and a height of around 4.6 meters. Its empty weight is estimated at roughly 18,500 kilograms, with a maximum takeoff weight exceeding 35,000 kilograms. The airframe features a blended wing-body design with carefully angled surfaces to reduce radar visibility, though its stealth characteristics are generally considered less refined than those of Western fifth-generation fighters. Engine inlets, external shaping, and partial use of radar-absorbent materials contribute to a reduced radar cross-section, but not to the same degree as aircraft designed with stealth as the primary constraint. Power is provided by twin Saturn turbofan engines, with early production models using AL-41F1 engines, and later variants expected to incorporate the more advanced Izdalai 30. These engines provide significant thrust, enabling the aircraft to reach speeds of around Mach 2. Supercruise capability is reported, but not consistently emphasized, and overall performance is geared towards strong acceleration and agility rather than sustained stealthy penetration at high speed. The Su-57 also features three-dimensional thrust vectoring, allowing for extreme maneuverability at low speeds and high angles of attack. a characteristic that distinguishes it from many Western designs. Avionics and sensor systems on the Su-57 are designed to support both stealth operations and electronic warfare. The aircraft is equipped with the NO36 Bielka radar system, which includes multiple active electronically scanned array radars distributed across the airframe. This provides broader coverage compared to traditional single radar configurations. In addition to radar, the Su-57 incorporates infrared search and track systems, electronic countermeasures, and data link capabilities, allowing it to detect and engage targets across multiple spectrums. However, the level of sensor fusion and seamless integration is generally considered less advanced than that of aircraft like the F-35. Operationally, the Su-57 is intended to function as a versatile combat platform capable of adapting to different mission requirements. Internal weapon bays allow it to carry air-to-air and air-to-ground munitions while maintaining a reduced radar signature, though external hardpoints can be used when stealth is less critical. Its design suggests an emphasis on flexibility rather than strict adherence to stealth doctrine, allowing it to operate in both contested and permissive environments. In essence, the Su-57 reflects a hybrid philosophy. It does not fully abandon traditional fighter design principles in favor of stealth and data dominance. Instead, it integrates elements of both approaches, creating an aircraft that prioritizes adaptability, maneuverability, and multi-role capability while still incorporating key aspects of fifth-generation technology. The Chengdu J-20 is often described as China's entry into the world of advanced stealth aviation, but that description alone does not fully explain what the aircraft represents or why it was developed. Built by Chengdu Aerospace Corporation under the broader aviation industry of China, the J-20 emerged as part of a long-term effort to close the technological gap with the most advanced Western fighters. Its development reflects a shift in doctrine, where air power is no longer just about numbers, but about detection, information control, and first strike advantage. The aircraft officially entered service in the late 2010s, marking a major milestone in China's military aviation history. From the beginning, the J-20 was designed not as a traditional dogfighter, but as a long-range high-end penetration platform. Its role is centered on gaining air superiority in contested environments where detection and reaction times are measured in seconds rather than minutes. This means the aircraft is built around stealth shaping, long-range sensors, and missile engagement rather than close-range maneuvering. Physically, the J-20 is a large fighter, significantly bigger than many of its Western counterparts. It measures approximately 20 meters in length, with a wingspan of around 13 meters and a height close to 5 meters. Its size immediately sets it apart, suggesting a design optimized for range and payload capacity rather than compact agility. The airframe uses a canard delta configuration combined with carefully angled surfaces intended to reduce radar reflection. While not identical to American stealth shaping philosophies, it still represents a deliberate attempt to manage radar cross-section across multiple aspects of the airframe. The internal structure of the aircraft includes weapons bays designed to preserve stealth during combat operations. This allows the J-20 to carry air-to-air missiles internally, reducing drag and limiting its radar signature when approaching hostile airspace. The aircraft is believed to be optimized for long-range engagements, with a focus on detecting and engaging targets before being detected itself. Powering the J-20 is a key part of its development story. Early production models used Russian-supplied engines, but newer variants are increasingly fitted with indigenous Chinese turbofans such as the Shenyang WS-10 turbofan engine, with future upgrades expected to include more advanced high-thrust engines. These power plants allow the aircraft to reach speeds estimated around Mach 2, although its operational emphasis is less about maximum speed and more about sustained performance at range. Engine development has been one of the most closely watched aspects of the program, as it directly affects stealth performance, endurance, and supercruise capability. The avionics suite of the J-20 is built around modern sensor fusion concepts, integrating radar, infrared detection, and electronic warfare systems into a unified operational picture. Its radar system, believed to be an active electronically scanned array, enables long-range tracking of multiple targets simultaneously. Combined with advanced data links, the aircraft is designed to operate as part of a broader network, sharing information with other aircraft, satellites, and ground systems. This network approach reflects modern air combat doctrine, where information superiority can be as important as physical performance. Operationally, the J-20 is intended to challenge high-value assets such as aerial refueling tankers, airborne early warning aircraft, and enemy support platforms, rather than engaging only in traditional fighter-to-fighter combat. By targeting these systems, it can disrupt the enemy's ability to coordinate and sustain operations over large distances. This approach reflects a broader strategy of degrading an opponent's network, rather than relying solely on direct confrontation. In essence, the J-20 represents a strategic shift in Chinese air power. It's not simply a stealth fighter built for parity with Western designs. It is a long range system built to reshape how air dominance is contested, emphasizing reach, awareness, and disruption over traditional measures of aerial combat performance.